Okay, whatever. Welcome. First try. Welcome to I forgot what I was gonna say. Java CP lesson number 3 about data structures. My whole menu is messed up. Don't see anything. Hold up. Where do I? Oh, I'm blind. Okay, cool. Now we're gonna start. What is a data structure? A data structure stores and organizes data for use. So, for example, you have books. Books organize pages, and pages organize words, and bookshelves organize books, right? Sock jars. You put your socks in there. You hopefully organize your socks in some way or form, unless you just have like a giant pile of them inside. That's not very good for you, but yeah, your socks are in the drawer. That's the point. And then you also have your computer's file systems. This is like a good example because you see that you have files organized inside of a bigger file. Yeah, I guess that's how I explain it. So now there's characteristics of a data structure. So we're going to be using a bookshelf for this entire slide. So lookup, where is a specific book on the bookshelf, right? And insert, how can I put a book on the shelf in like a specific place? Like, do you want it? Where do you want the book on the bookshelf? Remove, how can I take a book off the bookshelf? Like, how are you going to? Okay, wait, that's self-explanatory. Ordering, how are you going to sort the books on the bookshelf? So, like, are you gonna sort it A to Z? Are you gonna sort it by size? And size, can I resize my bookshelf so I can fit more books on the bookshelf, right? Those are like all characteristics of a data structure. Now, do you know these data structures already? Because if so, we don't actually have to go over them. I'm gonna put a straw poll in chat. Yes. I'm gonna put a straw poll in chat and like answer accordingly. I mean, these results are anonymous, so yes.
Wow, looks like a lot of people know arrays. All right, I think that's wait. Okay, there's 11 people. 11 minus
We
9.
should still go over them though.
Yeah. Okay.
Wait, hold up. This is a pretty this is a pretty dumb voting system, isn't it? Because you won't know if 100% of people chose that. It just says 38%.
Yeah, I should have had like a none of above option.
6 2 2 2 2 1 1. Okay, well, from the looks of things, I'm probably not gonna go over arrays. So, just unless I should I?
You can go over them like briefly. Yeah.
Okay, I'll go over them briefly. So here is here. Okay, what am I even saying? So when you're thinking of arrays, you think of a library. Each subject has an index, so you have index 0, 1, 2, 3, 4, just like in an array. And how can I find out which subject is at an index? And how do I store information at a certain index or just in the bookshelf or array itself, right? And using an array, you have like the data type, and then you have the name of the array. You say new, and then you put the data type again, and the size of the array within square brackets. Yep, self-explanatory. We start at index 0, So we have position 0, 1, 2, 3, even though we declared the size 4. But at size 4, you still have 4 positions. Right? Makes sense. Subjects 0, you'll have computer science. And if you want to change the position 0, you can say subject 0 is equal to whatever you want. So in this case, philosophy. Then over here, you would have in position 0, philosophy instead of computer science. Arrays, yeah, this is just horrible example of implementation, but this is a way you can do it, right? It's never good to hard code in your input unless you have a hard coded input. Other than that, this is a horrible example. Arrays practice quiz. So, your task? No, wait, Ryan, you didn't do. Okay, whatever.
Oh, I don't
So, on the okay, I can't see it because face cam, but oh, okay. Here on the right, there are like 3 burger choices and an option of no burger at all. So that in total gives you 4 choices, but you would access them as 0, 1, 2, 3, and you're storing the number of calories in each position. And if it's no burger, it's just 0 calories. How would you initialize this array? You would say int array calories equals the new int array 4. How would you set the calories for the fish burger? Since that's at position 1, you'd say calories 1 is equal to 431. And how would you display the number? You just system.out.println and the calories in square brackets 1, right? Simple. Now java.util.ArrayList. This is this is ArrayList but better in most ways. So the concept of an array list is basically an array, but its size can expand when it reaches full capacity, and it has more built-in functions. So array lists really just make your life a lot easier. So you can say name.add element, which extends the the array list by, I don't know, that space is just really triggering me. So when you do name.add, you add an element to the back of the array list. So if you had nothing in an array list, you'd have position 0 would be element, right? And name.insert at an index the element. This will put this element at this index in the array and push everything else in the array back, right? And name.remove index will remove this index from the array and move all the previous elements forward. There's really horrible slides, by the way. Adds the element at the end of the list. Yeah, okay, I actually just explained this. Whatever. So list.add. So you'll see if you do list.add Boris, you'll get from this list to this list, right? And it's the only bad thing about ArrayList is that it's a bit slower because each time you do .add, it actually creates a new array with 2 times the size and copies elements over if the size is too small. Okay, now you have list.insert, which inserts element at an index and pushes the elements on the right 1 space to the right. So if you have .insert 1 and Angela, you'll put Angela into position 1 and push Justin and Boris back, right? Now you have list.remove. It removes the elements at index and returns it, right? So if you say list.remove 0, goodbye Donald, everything moves and fills that position in. And position 3 wouldn't actually, wait. I'm actually not sure. Would position 3 still be a valid position within the array?
Well, it would result in array like the out of index exception, because even though like the array behind the array list like is of a bigger size, it's not going to let it access that index anymore, right?
Yeah.
So like if it shrinks to like a certain amount, like they'll just copy the elements over and make a smaller array.
Feel
So
like
it would just be like the reverse of like the addition thing.
this diagram's kinda
Yeah.
off, not gonna lie. And now you have list.get, which is how you access your elements in an array. Interesting choice of names. So now you can .get literally any position in the array, but if you say .get 3, since Angela, Justin, and Boris are the only elements left in an array, and position 3 is no longer anything, you cannot get that, and it will give you an out of bounds exception. And to loop through an array list, it's just like, literally just like an array. It's the exact same way, except you have to do list.size instead of your array name .length, right? That's the only difference. Or you can also do this, which is for string name colon list, and then just print out name. This one's like the nerdier way to do it. This one's a bit more flexible sometimes though. So now you have zero that out. This is a question. So your boss, wait, don't.
Do you want me to go over this one?
Yeah.
Yeah, okay. So basically, your boss asks you to add up a sequence of positive numbers to determine how much money your company made last year. And unfortunately, your boss reads out numbers incorrectly from time to time. Fortunately, your boss realizes when an incorrect number is read and says 0, meaning ignore the current last number. So when you say 0, you're basically saying remove the last thing that I just said, right? Unfortunately, your boss can make repeated mistakes and says 0 for each mistake. So for example, your boss can say 1, 2, 1, 3, 5, 4, 0, and 0 gets rid of 4. And he says 0 again, and it gets rid of 5, right? And then he says 7, and then he says 0, which gets rid of the 7, right? 0, which gets rid of like some previous number, and then 6. So basically, when you get 0, you just remove the last element, right, that he said. So can you move on to the next slide? Yeah, so basically what your solution is that every single time your boss sets a number, you put it into a list, right? And when your boss says 0, he means remove the last thing that I just said, which means the number at the end of the list. And how you can do that is by using list.remove, and in the parameters, you'll put list.size -1. And list.size -1 is the index of the last element in your array list. And the reason that is because your array list is 0 index, just like an array. So it starts at index 0. So your last element would just be the size of your list -1, and you would remove the last element. And otherwise, you would want to add the non-zero number to the end of the list using list.add, and then you would pass the element in the list.add. So that would be the number that your boss has just said, right? And so after you've done all of this, right, like checking if it's 0, and if it's 0, you remove at the end of the list. If it's not 0, you put it into the list, right? After doing all of that, you can just add up all the numbers that are left in the array list, and that would give you your answer. And there's the code on the right. So I named my array list int r, right? And I'm looping through every single number that the boss says. And if x equals 0, which means the boss's number equals 0, I remove at the end of the list. And otherwise, I would just add at the end of the list. And after doing all of that, in the end, I loop through the array list and add up all of the numbers remaining. And then that would be your answer. Yeah. So yay. You know how to solve like an array list problem now. Hey, okay, I'm gonna screen share now. Okay. Whoops. Okay, so we're gonna talk about HashMap now. Great. Yay, HashMap. So it's actually part of a class called java.util.hashmap. It's something that you have to import. It's basically code that someone else has written already, but you can use it. So hashmaps are really useful in competitive programming. And if you've stuck with us the whole way, you know what this video is. And in the video, the guy uses a hash map. So yeah, so you can check that out and see how he uses HashMap to solve his problem. So basically, let's think about what exactly is a hash map, right? You've probably never heard of the word hash before or map before. Well, map in like the sense of like looking up a place, right? So hash map is actually about like looking up things, right? So a hash map creates a relationship between a key and a value. So for instance, if you see the diagram on the right, it creates a relationship between my subject and my grade, right? I tell the computer, I want these two things to be related to each other, right? So if you use this function map.get a key, you pass in the key into the .get function of the map, it returns the value associated with the key. So for instance, if I do map.get CS, I would get 100. If I do map.get English, I'll get 85, right? So I'm linking these two pieces of data together using this hash map. So that's the power of what you can do with a hash map. You can literally link any two pieces of data together using a hash map. And it does not work the other way around. So I can tell the computer, hey, I made this really cool hash map, right? And I want to see what my grade is for CS. So I do map.get CS and I get 100. But I can't tell the computer, hey, I gave you this hash map. Can you tell me which key has the grade 100? I can't do that. Hash map is like a one directional relationship, right? I can't go from value back to the key. You can see this arrow. It goes from the key to the value. I can use CS to get 100, but I can't get it from the 100, get the CS. And the reason why is because there can be multiple subjects where I can get 100. Whoa, mind blowing. Oh my gosh. Yeah. In reality, I'm not that good, but let's just assume that for English, I got 100 as well, right? So I tell the computer, hey, what is the key associated with 100? And it can't tell me that because your computer would be like, which one am I referring to? Am I trying to get you CS or am I trying to get you English, right? So it only goes one way, key to value. And keys must be unique. So I can't have two subjects that are also called CS because your computer would just be really confused. So all of the subjects have to be unique in the hash map. So yay, concept check. So I want you to tell me what is the key and what is the value. Remember, I'm using the key to get the value, right? So you can think of a key like a physical key, like opening up a door. And if you open that door, you get the value. So the hint is you want to rephrase as I want to use this to access this. And if you can fill in those words, then you know what the key is and what the value is. So given a friend's name, I want to know their birthday. So if I'm storing this in a hash map, what would be the key and what would be their value? Just put it in the chat. A strange way to say Albert's grade. Yes. Or is the Albert? So key equals name, value equals birthday. Very good. So yes, in this case, your key would be your name and the value would be your birthday. So I just pass in a friend's name into the hash map and the hash map will give me their birthday. Yeah, good job. Okay, given a student's name, I want to find out their student ID. I mean, this has a little bit of privacy issues, but like otherwise, let's just use this example. What is the key and what is the value? Any ideas? Yeah, so the key would be the student's name and the value would be the ID. So I would pass in a student's name into this hash map and the hash map will tell me the student's ID. So your key would be your name because you know that person's name and you feed it into the hash map. And the value is what you get back from the hash map, which is the student's ID. And so you can store the name as a string and you can store the student ID as like an int or a long, right? So I want to know the address of a school. So what can be the key and what can be the value? This one's a little bit more open-ended. So let's just say like I'm like searching on Google and I want to know the address of the school. So what would be the key and what would be the value in this case? Yeah, so school and your address, right? So I can pass in school's name into the hash map and it will give me the address. Yeah, great. Last one. I want to search up the definition for a word. So yeah, so what would be the key and what would be the value? So you can actually use the hash map as a dictionary if you want. You can actually make that program. Yeah, so word and definition. So your key would be your word. I'm giving in the word into the hash map and the hash map will tell me what the definition is that is associated with the word. So yeah, so I hope you all have a better idea of what a hash map is. How you can use a hash map is that you just give them a key and it'll return a value to you. And you can store these kinds of relationships. Okay, so how do you create a hash map? So it's kind of similar to ArrayLists because you have to use these fancy brackets, right? So how you declare it is hash map and you give in the type of the key, right? So for example, if I'm storing like my grades and my key would be my subject, right? Subject is going to be a string. So here's a string, right? And you want to pass in the type of the value. So that would be my grades, and my grades is a number, so I can use an integer to represent that. And the name of the hash map, so I just call it map because I'm unimaginative. You can probably come up with a better name for a hash map. I'm just going to call it map. And you can do equals new hash map. So you're always going to have this. This is going to be the same no matter what. So yeah, so that's how you create a hash map, the type of the key and the type of the value. But remember, you have to use the full out spelling. You have to use integer, long, string, character, and Boolean. You can't use the lowercase int, long, right, string. Like string is always uppercase, but like you can't use char, right? So don't use like the lowercase ones. Always keep it uppercase, and that's because it has something to do with objects, and we're not going to touch on that right now. But just make sure you spell it out like this for your types, and it creates an empty hash map. So it has nothing in it right now. Okay, so this is how you create a relationship between a key and a value. So it adds a key value relationship. So I'm telling the program, hey, if I give in this key, you should give me back this value. So that's how you're storing the information. And if the key is already in the map, so for example, if I already have CS in the map, it would just overwrite the previous entry. So because you can't have duplicates. So for example, I have subject and I have grade, so the key and the value. So I'm going to put CS and 100 because I want to say, hey, map, when I pass in CS, you better give me 100 or else, right? So it creates CS as a string, it creates 100 as an integer, and this dot put links them both together. Whoa, it's like magic, right? And I do map.put English and 85. So I say, when I use the .get command, you better give me 85 when I give you English. So it creates English, creates 85, and creates that relationship with these two pieces of data. So map.put CS and 65. Oh wait, that should go chemistry. Oops, I messed up, sorry. It should say map.put chemistry and 65. So when you put in chemistry, you better give me 65. So it creates that relationship. And, oh, okay, I made a mistake there, okay. It should be physics. So map.put physics and 70, right? And you create that kind of relationship. Sorry, this should be chemistry and this should be physics. Yeah, so that's how you do .put. You're making a relationship between two pieces of data so that in the future, when you have to access it, you can use the map to access it. So this is how you create relationships. And yeah, and when you want to get that relationship, you would use map.get and you pass in the key. The key is the information that you already know. So you get the value associated with the key. So for instance, if I have a key, I'll pass it into the map.get function, and it will give me the value that's associated with it. So if I'm passing in CS and I pass it into the map.get function, it gives me 100, right? You can think of this kind of like a factory, right? You put it in and it gives you something, right? You have an input and it gives you output, right? So you're basically accessing this relationship. And this is how you use a hash map. So map.getCS gives me 100. And if I pass in English in here, map.getEnglish, it's going to give me 85. So I'm using this relationship finally to, from the key, I can access the value. So that's how you use HashMap. So .put creates this relationship, and .get lets me access each key's associated value. Yeah, cool. And so how do you loop through the keys in a hash map? So you would use a for each loop. So you have to use a for each loop or iterators, but this is the most simple example. So you would use a for loop. You would say the data type of the key. So my courses are all strings. So I would say string. And this is the temporary name of the key. You can call it anything you want, but this is the name that you're going to use when you're referring to the key in the for loop. And then you would put the name of the map here and .keyset. So this returns like a set that you can loop through. And you can print out the key and the value, right? So the key is course, as we've defined here. And map.getCourse gives me out the value that's associated with that course. And you have to be really careful. It's not guaranteed to print out the keys in the order you added them. So it can be a different order every single time you print out the keys, because it's like random. It's not like an array list. So yeah, so a potential application of a hash map would be to check frequency. So for example, you want to find the most frequently occurring string in a list. So someone gives you a bunch of names and they're like, give me the most frequent name, right? So your key would be, well, a string, right? And your value would be the frequency. So how many times that string will show up. And how I can do this is first, I need to add all the strings into the hash map. So here, this is where you add all the strings into a hash map. So what I'm doing, this is the number of strings that I'm reading in, and I loop n times, right? And I read the string. And if the map already has the string, right? Because there can only be one string, like one of each string inside the hash map, right? So if it already has that string, get the value in the map and add 1 because you've encountered it one more time, and you would put it back into the map, right? So this is how you update things. You're like, is it already in the map? If it's already in the map, get it for me, add 1 to it, and put it back into the map. And this would overwrite the previous entry because there can only be 1 of each type. If it's not in the map, then you would just put it into the map with a value of 1 because, well, if you've encountered it for the first time. So any questions about this? Like how you can add strings into the hash map? So first, you read the string, you check if it's in the map. If it's in the map, get the value, add 1, put it back into the map. And if it's not in the map, just put it and give it a value of 1. And here, this code is to determine the maximum frequency. Oops. Okay, yeah, you can see it here too, using Replit. So here, you can see I'm storing the most frequent string and the maximum frequency. And so I can loop through the keys of a map and check what is the frequency of this string. And if that frequency is greater than my current maximum, then I would make the most frequent string to be this string and the most frequent frequency to be this frequency. And then I would just print it out at the end. Yeah, so this is how I can find like the maximum frequency in this case. Yeah, I hope that's clear. Do you guys want me to go over an example or? Okay, so let's just move on. We can take up this example next week if you want. Like, you guys should really try out this problem. It's very similar to this problem. You can literally take like a piece of this code and use it for this phone book problem. I'm going to give you a hint. It uses 2 hash maps. So try to solve that problem. If you have any like problems, just come to me and I can give you some hints. Okay, 2D arrays. This is the last topic, so you can breathe a sigh of relief. Yay. Finally, we're at 2D arrays. Okay, so what is a 2D array? It's literally like a grid. Like if you've played chess before, you know, like these kind of grids are pretty familiar to you, right? So it's an array of arrays. So I know you can make an array of integers, you can make an array of strings, you can make an array of Boolean, but what if you made an array of arrays? That's some big brain knowledge, okay? So you can view it as kind of like a grid. So I'm making a 2D array here. So you use 2 brackets instead of 1. And you would do int and then whatever name for your 2D array equals new int, number of rows and number of columns. And your type could be int, char, boolean, long, pretty much anything you want. And so you can see here, you have rows and you have columns, right? And some data types have default values, which mean that if I just make this array, it'll be filled with like 0 or it'll be filled with like false, right? So if you do a number, they're going to be automatically filled with zeros. If you do a Boolean, they'll be automatically filled with false. So yeah, so but if you make an array of like a 2D array of strings, it's probably all null. So you have to be careful about that. So let's practice a little bit about 2D arrays and how we access things. So for example, I have this 2D array, right? This is row 0, column 0, row 0, column 1, row 1, column 0, row 1, column 1, right? So this is how you can access things, is that R at C, which means the element at row R and column C. And if you want to know what the top elements are, well, you look at here. I'm using R at C, right? So what I'm doing is that this is array at 0, 0. This one's array at 0, 1, because row comes before column. And if you want to know what the bottom elements are, they're array at 1 and 0, and the array at 1 and 1, right? So you kind of have to wrap your head around that. So these are the top elements, these are the bottom elements, and I want to flip them. I want this one to go here, I want that one to go there, and vice versa. So how can I do that? Well, I'm going to save the top variables as like temporary variables. So I'm going to hold them using different variables. And then I make the bottom equal to the top, right? And then the temporary variables at the top go in the bottom. So this way, I can swap the variables. So here I have 0, 0. I save this. I save 0, 1. And 0, 0 equals 1, 0 because I'm moving this up. 0, 1 equals 1, 1. So this one moves up. And then I move these numbers down, right? Because they're stored in temporary variables. So I'm not losing any information. And similarly, you can flip on the y-axis. So all you have to know is the left elements are 0, 0, and 1, 0, right? Because row before column. And the right elements are 0, 1, and 1, 1. And how you swap them? Well, you store these in temporary variables. You move the right ones to the left, and then the temporary variables to the right. So same kind of idea. And what you should get at the end is you've solved this problem already. So amazing. Yeah, so this was last year's problem. So if you basically know where everything is at, right? If you know this kind of system for making 2D arrays, then you can solve this problem. Great. So how do we loop through a 2D array? Well, you can use two for loops. So the first for loop goes through the rows, and the second for loop goes through the columns. So let me trace this algorithm. So it might be easier that way. So here I'm at row 0 and column 0 because they're both starting at 0, 0, right? And here I print out the element, right? And then it breaks out and it goes back in here. So I have row 0, column 0. It goes to row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4. And then here it leaves this for loop and it goes back into the big for loop, right? So I'm at row 1 right now. So row 1, column 0, row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4. And then it leaves this for loop because it's C is equal to R at R dot length. So it's breaking out of this for loop and it goes back into the big for loop. And then I'm at row 2. So 2, 0, 2, 1, 2, 2, 2, 3, and then 2, 4. So that's how you can loop through a 2D array. And I'm just printing it out, all of the elements. So yeah, so that's how you can loop through a 2D array. Yeah, so I'm going to have you guys practice 2D arrays by making a multiplication table, right? So every at R and at C is equal to R times C, right? So you can go up to 12 times 12, you print out the multiplication table, and it should match this picture on the right. And once you're done, just link your Replit to the chat, and we'll try to demo your multiplication table. Yeah. I'm going to go back to the previous slide so that you guys have like a reference on how to loop through 2D arrays and try to make your own multiplication table. Yeah, so you go up to 12 and you go up to 12 here. So yeah, so make your own multiplication table. Oh, it's okay. Like, even it might not like look exactly like the one that I showed you. You can just copy the link at the top, like if you're using Replit. And if you don't have Replit, you can like make an account and then just paste your code there.
I just realized I was actually talking muted.
Oh yeah, you know what? That happens to me a lot. Yeah.
Yeah.
Yep. All right. Okay. Yay. Okay. Let's try it out. Whoa! Yay! It works. It doesn't look wonky at all. I think it looks really good.
I think it only looks wonky because of the spacing. I think that's what
Yeah.
she meant.
Well,
So there's like a way to deal with that actually, but we didn't teach it, so honestly it doesn't matter. Good job.
yeah.
we should have taught them formatting actually.
Yeah, maybe
But
that'll be the next lesson. We can put it in the next lesson. Like,
I mean, I can show how to do it really quick. It's pretty simple, isn't it? It's just detecting how long, how long the number is. Very sad praise, but I'll take. What do you mean, very sad praise? I said good job. What else do you want me to say? Oh my God, you're my big. No. The only
oh
like,
wow,
oh wow, you're
that's
so
very
good at
supportive.
programming. You're better than me. Yes, stay sad. Uh-oh.
Yes, the CS community is very supportive. Yeah, but kudos for having courage to show your multiplication table.
Yes. Let's see.
Jake, you want to show them how to format?
Sure. I don't know if it's the same because there's that F format thing, and then there's that like just checking how long the number is.
All right. Okay, so I can show one method of doing it. It's using this.
Sure.
Oh, okay, I need to fork it first. Okay. So there's one method of doing it is to just convert the integer to a string. So I can use string and I just give it like a name and integer dot toString and I pass in like an integer. So this converts the integer to a string. So now if I have 1, 2, 3, it would become 1, 2, 3, right? So it's a different data type now. It's a string. And you know what you can do with strings? You can find out how long it is. So s.length. Great. So you know how long the string is.
Wait, can't you do that on the same line?
I could. Honestly, I
Okay.
could just do that.
Eh,
But just,
Actually, no,
to
it's clearer this way. You can keep it like that.
yeah. So what I can do is that okay, so you know the largest number. The largest number is going to be 12 times 12, right? So that would be and I can convert this. Well, I know it's 3, so I'm not going to do it. So 3 digits is the most, right? So if length, so I can do let's see, 4. And how much padding do I need? Um,
If you know the length is 3, then all you need to do is just take another integer, right? You don't need a for loop to do that, do you?
well, okay, I'll just do a for loop this way.
Okay, then.
Yeah. Well,
Oh, wait, never mind. I forgot. This isn't Python. Python, you can just multiply strings. My bad.
let's try that out.
Replit being slow. Yep,
All
that's
right,
nice.
that works. So what I was doing here is that I converted the integer at R at C to a string. So I call it S. I can find out how long it is. And then I just print it out. And now I have to determine how much spacing do I need to put after that, right? So the amount of spacing is 3 minus length plus 1, which is how many times this for loop runs. Because 3 is the maximum length of a number in this multiplication table, right? So 3 minus how many numbers, how many digits I already have is how many times I have to print out a space to like format it. So for instance, if I had 1, then I would have to print out 3 spaces after that because I have 2 spaces to accommodate for the missing digits and I have 1 space to separate every number. So that's one way that you can do that, is that you do this 3 minus length, find out how many digits are missing, right? And then fill them out with spaces and then add 1. So that's how you can format your multiplication table. So it's pretty neat, right? Time for substring. Oh, yeah, you can use other string methods as well. And yay, we taught you that before. All right, so if you want to showcase your multiplication tables, you can put them in the Discord chat and we'll rate your multiplication table to our heart's content. All right. Okay.
ArrayLists, but for programmed multiplication tables.
Yeah, okay. So these are some practice problems you can do. This one we took up in class. These 5 you can do on your own. Some of them are more tricky than others. If you need any help, just let us know. And yay, it's time for Kahoot. Who doesn't love Kahoot? Okay, I'm gonna make a Kahoot and you guys can join. Okay, oops. Wait. You guys shouldn't see that. Okay, so okay, here's Trisha 2001, and let's play it. Okay. Um, Oh no, it's Screenfoot.
Oh no, it's Greenfoot. Get him out of here. Ban him. Nobody likes Greenfoot.
If you guys are in grade 11 and 12 and you've taken computer science, then you know what Greenfoot is. If you don't, then it's just another way to use Java to make games. Hey, no dissing Java like that.
C++.
If you think Greenfoot is a bad software, Pygame is pretty tedious in comparison.
Pygame is fun to use. Okay, I'm defending Pygame.
Where's everyone else? We have 4 people. Okay, we have 6. Great. 7. Is that almost it? Well, 11 minus 2
Yes.
is 9. We're missing 2 people.
Maybe people don't want to play. Is that? Almost. Wait a minute. Do we start?
Okay. Is everyone in? I'm gonna give you 10 seconds to join if you're not in.
Do
10,
do 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 do.
9, 8,
They changed the
7,
music. It's
6,
Christmas themed now.
5.
Wait,
4,
it is?
3.
Oh my god, it's
2,
actually
1.
Christmas
Okay, yay,
themed.
okay, let's start.
Oh, I want to join.
No.
You're too late.
Well,
You can still join. It's just
Yeah.
the link.
Oh, okay.
This is the
tough.
answer is actually C, all of the above.
All right.
Because yes, they use letters here.
They're immutable. You can't change the size of arrays. So like when I was giving the array list example, you had to it copied all the things from the previous array and made a bigger array. Whoa.
Greenfoot. Why is everybody called Greenfoot?
Yes.
How do you make? Why don't you have an all of the above option, SMH?
Oh yeah, all of the above. You can use all of the above.
Yes.
Baby. I wonder.
Great.
All right, okay. Yeah, so you use this, you have to use integer. This one's an array, so, and this one,
It's missing the triangular brackets.
yeah.
Time to shamelessly promote Python CP by saying you don't have to do this complicated thing in
What happened
Python.
to C++ is big better than Java.
Everyone's dissing Java right now. Why are we still here?
All
just
right.
to suffer?
Yes, you are the suffer.
Imagine using Java, SMH. Can't relate.
Lol. You have to see the picture. Or it doesn't actually matter, the picture.
Yeah.
Yay! Everyone got
Whoa,
that
nobody
right.
got it wrong.
Woohoo!
Wow, we're successfully teaching them.
Yeah, hope so.
I hope so. Yeah.
Woohoo!
Yay.
Yay, we got that. All right.
Greenfoot is in 3rd place. Oh no.
Should be in last, please.
Yes.
All right. So you use .key, .get key. Whoa.
Greenfoot, more like stinky foot, am I right?
Wait, Matthew, you recorded, right?
Yeah, I recorded the meeting.
Cool. As long as you did everything.
Yay. So I remember that grades example, like where you have to I can use my subject to get the grade, but I can't use the grade to get the subject because there can be multiple subjects with the same grade. And if you use the grade, then the program doesn't know which subject it's supposed to tell you, right? Yay, okay.
Tufnjörg. How do you pronounce that?
Oh no, it's Greenfoot.
No, who done it?
Who's number one? Okay.
Okay.
Okay,
All
okay.
right. All right.
Okay.